Welcome back. In this lecture, we'll briefly discuss one of NumPy's central features, the Ndarray. It's the crown jewel of the package and the reason NumPy is as commonly used as it is. So, the name Ndarray is short for n-dimensional array. The dimensionality aspect comes from the mathematical expression of these arrays. In natural sciences, a point, a line, and a plane represent objects of the 0th, 1st, and 2nd dimensions, respectively. Additionally, a plane can be looked at as a sequence of infinitely many lines placed next to one another. And a line can be looked at as a sequence of points. Hence, sequences of n-dimensional objects make up an n+1 dimensional object. The exact same logic applies to arrays. A 0D array is just a single data point, while a 1D array is a sequence of values. In the same line of thoughts, a 2D array is like a collection of 1D sequences. But to explain how this translates to data, we'll need to create an ND array. So, start by defining a variable. We'll call it array A, and set it equal to np.array, followed by parentheses. Then, within the parentheses, within squared brackets, we write some numbers separated by commas. This line of code generates the ND array, but provides no output. If we call the variable array A on the next line, we'll also see it displayed on the screen. What we see on the screen is the word array followed by a sequence of numbers. Hence, we just defined our first 1D array in Python. If you're familiar with linear algebra, you can think about arrays as vectors. The variable we just defined was like a vector, which is one-dimensional. Additionally, 0D vector is a scalar, which is a single value. And a 2D vector is a matrix. Now, if we want to create a matrix in NumPy, we simply need a 2D array. Let's do that now. Copy the code we just wrote and paste it into a new cell and change the name of the variable to array B to avoid confusion. Next, after the 1, 2, 3, place a comma and add another 3 values within squared brackets. Make sure to also change the name of the array variable on the second line and run the cell. The output shows a matrix where the first row is the initial array we had, whilst the second row consists of the values we added later. Hence, this 2D array is just two 1D arrays stacked on top of one another. Alright! So, ND arrays are useful because they are the easiest way to use linear algebra in Python. Just like matrices and vectors, we can conduct element-wise operations on them. Great! Now that we've discovered why we want to use NumPy, we're ready to see how we're going to use NumPy. In the next lesson, we'll examine NumPy's documentation and learn how to navigate it best. Thanks for watching!